Okay, we've made it to the third and final part of the lesson where we're going to add in animation. So there's a couple of things going on here. When we tap the popcorn popper, it should expand just like that. And we also want the kernels themselves to shoot out with some random amount of height, either going to the left or the right, a random amount of distance, and they should also nicely fade out after a certain amount of time. And that will take us to the final product looking more or less the same as what we have there. So to accomplish all of this, we're going to use a library called Framer Motion. This is a very easy to use and powerful library that gives you tons of flexibility in the kinds of animations you want to add to your components with very few lines of code that just look smooth and beautiful right out of the box. So this is just a regular node package. Normally, you would want to add it. This would be run in the directory of your project. I've already added Framer Motion to the project we're working in here, so we're not going to run that command again. Instead, we're just going to go ahead and import the library. So there's a couple functions we're going to use here, but the first thing we want to pull in is this motion. And what this allows us to do is easily turn any component here into what's called a motion component. And we're going to first demonstrate this by adding the grow effect to the popper when we tap on it. So this is very, very easy to do. To turn a component into a motion component, all we do is add motion dot in front of it. So this div is now a motion div. We could do nothing else, and this will still work the exact same as before, but because we've actually turned this into a motion div, we have a few other functions that we can add here now. And the one that we're going to add is while tap. So if I just type while, you see there's a bunch of functions here from Framer Motion that let us add certain animations while we're doing certain things to that element. But we want to look at while tap for this example. So we're going to add while tap, and that's just going to do a scale. So we want to scale it by 1.4 times. And that's all we need to do. If we tap this, notice that now this has this nice grow effect. That was super easy to do. We could configure this further in terms of how quickly it scales, maybe the timings, anything we really want. But this looks pretty nice as is, and that's one of the nice things about Framer Motion. Their default settings generally look nice enough for what you want to do, and usually additional configuration isn't really required. So that's all we're going to do for this popcorn popper, and this already looks the exact same as what we had in the finished product. So we're actually finished with the popper component. Everything else is going to be done to the kernels now. So let's move down to our kernel component. And similarly, we're going to be animating these kernels, right? And that means that the parent component, which is just this container for the overall kernel, needs to be turned into a motion div, exactly the same as we did with the popper. And this one's going to look a little bit different. There's sort of three states here if you think about the animation. We have our initial or beginning state. We have the final state that we want it to animate to. And we're also going to add in an exit animation, which is the animation that plays when the kernel component is removed from the page. So all in all, these three animation states together are going to give us that final animation. And motion div makes this easy to do. We're going to use what's called a variance constant, and that's going to define our three animation states for this kernel. So the way this is going to look is I'm going to type in variance, and this is just going to be kernel variance. Don't worry about the linter complaining. We're going to define all of these. We need to give it an initial state. which we're just going to call initial. We need to give it an animate state, which we're going to call target. And we need to give it an exit state, which we're going to call exit. And right now, this isn't going to do anything, but this initial, target, and exit states are going to correspond to the variance we have here. So let's go ahead and define that now. So the variance themselves is really just an object, and this can have as many keys as you want. The important part is that the name of those keys have to correspond to what you have defined as the initial, animate, and exit states. So in our case, we have three, right? We have initial, we have target, and we have exit. So this is going to compile now, and it's not actually going to do anything yet because we haven't defined anything for these states. So just for the sake of example, let's do something really simple. Let's imagine we want these kernels to fade in. So the way we're going to do this is add opacity 0 as the initial state and opacity 1 as the target state. This isn't going to be our final animation, but it's a pretty easy way to demonstrate how powerful and easy to use framer motion is. So now when I tap this, do you see that? It's a little hard to see here, but it actually fades into view. Similarly, we could do something with the Y position. Let's say initially, the Y position of this kernel is just going to be 0. So that's basically its starting position. And we want it to float up. And we can do this by adding an arbitrary value. Let's just say minus 100. So this also is, the y-axis is positioned in such a way that 0 for the y position is going to be your start. As you increase the y position, you're actually going down. And as you decrease it, you're going to be going up. So this means that the kernel should fly up. And look at that. So that works pretty nicely as well. And something we can even do is add another property to this motion div called transition. This lets us define additional sort of customizations to the animation. For example, we can set an explicit duration. If we want this to be really slow, we can make it last 5 seconds. So if I tap this now, that didn't work. This might be too high of a number, to be honest. Let's try 0.5. There we go. So this is a little bit slower now. If I do 1 second, yeah, that's even slower now. And it's still disappearing because remember, we have this timeout to 250 milliseconds. So anything above that is not going to complete the animation in time. So for now, let's just set this to 0.75, which is actually going to be our final duration for this animation. And the other thing we want to do is give this a different type. So by default, the animation itself is pretty smooth, but it has a constant speed throughout. To emulate this effect of kernels popping out of the popper, we want to start really fast and then kind of slow down towards the end. And this is going to look nice because it'll give this effect of kernels quickly shooting out of the bag of popcorn and then slowing down as they start to fall and eventually fade out. So again, we can see that looks okay. I mean, obviously, it's not perfect in that the kernels just disappear and there's no exit animation yet. And there's also no variability. So the next thing we want to do is make these kernels fade out when they are removed by the kernel controller. And the way we're going to do that is add a property to this exit. And we're going to give this opacity 0, and we're going to put this back to opacity 1 so that initially the kernels are visible. So you would think that this would do something, but it actually doesn't yet. When the kernel's removed from the screen, it just immediately disappears, right? And the reason for that is we're missing another property that Framer Motion provides, which is called animate presence. This animate presence component is required for any exit animations to work. And what this does is if you wrap anything that is conditionally rendered, so let's say here, we're going to add an animate presence. So we're wrapping all of our child kernel components in this animate presence component. That means that any direct children that are a motion div, or any motion components that are direct children that also have an exit animation, will this animate presence will ensure that their exit animation fully plays before it's removed from the page. So now, because we did this, if I click on the popper again, now that actually works. See? It has this fade out effect before it's removed. Great. And the other thing to note is that any direct motion components of this any direct components of the animate presence component also require this key property. In this case, we already have the key because it's also required by the map. But if, say, you were only rendering a single object, like, is my component visible and my component, something like that, if this my component had its own exit animation, you would need some key that you could just hard code for this to work. So I'm going to get rid of that. Cool. So this is coming together now. So really all that's left is to define a few more interesting fields to this animation. So what we're going to do is first add a bit of randomness here. And how are we going to do that? Well, when each kernel is rendered, we want it to have a set of animation values. And we're going to do this by defining a new constant. And we need to use the useRef hook here as well. I'll get to that in a second. And what animation values do we care about? Well, we're going to have a max height. We're going to have an offset X. And we're going to have a rotation. And this is cheating a little bit. I already have a utility set up. So there's a function here that I created called getRandomArbitrary. And this is just going to give me a random number between the two numbers that I define. So for the height, I'm going to say 70, 90. Offset X, I'm going to say between -40 and 40. And for rotation, I'm going to say it's between 0 and 360. And like we've been doing this entire lesson, animation values is not defined yet. So let's go ahead and define that. Animation values. So we have our max height, which is a number. We have our offset X, which is a number. Should be lowercase. There we go. And we have a rotation, which is also a number. So now that we have our animation values, what we're going to do is pass this into another property that the motion div provides, which is called custom. And we're just going to give it animation values.current. And this is why I'm using the ref here, because if I didn't do this, every single time this kernel re-rendered, it would get different random values for the animation. And then this animation would get all messed up. We want to ensure that the same values are used between renders of the kernel. So using a ref like this with .current is a really easy way to do that. So now that we've defined our custom values for the animation, we need to actually use this custom value in our variance. So it's important to note that this variance and custom properties are very heavily tied together. Because I added this custom key here, I can use this value in any of my variants to further customize it. So what that means is here, if we go back to the target, Right now, it's just hard-coded as having y negative 100. But we want this target to depend on these animation values. So instead, we can actually turn this into a function that takes the animation values and returns an object. So that's all this is doing. And now, instead of the y just being negative 100, we actually want it to animate to, so we kind of want 3 keyframes here, right? We want it to start at 0. We want it to animate to max height. And notice I put a minus here because we want it to animate up. And at the very end of the animation, we want it to have fallen back to its starting position. And then we also have an X animation in the position now. And that's going to be animation values.offset X. And we even have a rotation, animation values.rotation. So what does this mean? When this kernel is animated, it's going to start at 0. About halfway through its animation, it's going to have reached its max height, and then it's going to start falling back down to its original position. The X position will animate to whatever its final offset is at the very end of the animation, and it will also rotate to some final degrees between 0 and 360. So now, if I tap this, we should get our final animation. Look at that. So there is one issue here. Does not seem to be rotating. I think I may have used the wrong key here. Is it rotate? There we go. That's why. So instead of rotation, I needed rotate. You can look through the framework motion docs for all of the valid keys here, but there's quite a bit you can do. You can even, for an SVG, you can change paths and strokes and colors. You can change positions, you can scale, opacity, rotation. There's tons of stuff you can do here. But that's pretty much all we're doing for the sake of this one. And this looks pretty nice now, right? I can tap this as many times as I want, and kernels will just continue to shoot out. And that's actually more or less everything we have for the lesson. If we look back at the demo, it's actually basically the same at this point. The kernels are a little bit smaller, the sizes are somewhat different. There's this tap to make popcorn text, but other than that, we created the same component, right? We can click this as many times as we want, and we get that many kernels shooting out. Cool. So the nice thing here too is that because this popcorn popper itself is a component, we could also export this and we can render as many of these as we want, right? Like here, we're just rendering a single popcorn popper, which again is, if we go all the way back to the beginning, this thing only needs to know how to render a popcorn popper, and it doesn't need to know anything about the specifics of what a popcorn popper looks like or does. And because we defined it this way up front, now we can really easily just create as many of these as we want. And they'll also be arranged however we tell it to based on our parent container. So now we're going to have 3 popcorn poppers, and they all function independently, right? They do the same thing. And we could do things like change it from a column to a row, and that's also going to work. And we can even make this a smaller container if we wanted, and basically just do whatever we want with this component. So you can maybe imagine how if this was anything else, depending on what kind of project or layout you're designing, you really could just reuse this very interactive, dynamic, and engaging component however you want in your layout. And that's really what I'm trying to emphasize here, is that with pretty minimal amount of code, this is 124 lines in total, we were able to create this really nice, easy to use, interactive component. So thanks for tuning into the lesson. I hope you learned something new. Let me know if you have any feedback or questions, and especially anything you'd like to see next. See you next time.